So, good morning. Today, on August 15, India is celebrating its Independence Day, and I'm very happy, extremely happy that our mathematics event, Math Ecstasy, is happening on the same day. The invited talk on role of mathematics in cybersecurity by Dr. Avishek Adhikari is organized by math aspirants WhatsApp groups and online mathematics exam series Google groups, joining hands with Career Development Center, Perambra, Kozhikode in Kerala. So, guys, mathematics is a magical subject, and I hope everyone here loves mathematics a lot. And that is actually the power which unites each of us right here and beyond boundaries. I must say, beyond boundaries, because we have got around 31 participants from outside India. That is a fabulous thing. And we have registrations from obviously all over India and from Saudi Arabia, from Pakistan, UK, Nigeria, Thailand, Iraq, etc. And even the posters were shared in different platforms so rapidly in our language, we can say it got viral. These are all good news, surprising news. And all these positive reports are actually the fruits of sincere dedication and restless hard work of some teachers and students and well-wishers for these days. But I can't say further without mentioning the name Dr. Vinod Kumar P. He is the assistant professor in TMG College, Tirur, which is in Kerala. During these pandemic days, he have taken a lot of initiatives to make people study mathematics. The WhatsApp group he created in 2017, namely Math Aspirants, is now a very good platform to discuss maths. And also he is conducting online exams through Google groups and by Google Forms. And he's making a good follow-up of those exams. So, and recently it has got a national attention. It has been published in newspapers. So it is seriously helping many people for preparing their exams. And Math Ecstasy, an odyssey through mathematics, is the product of effort of many of these people, and obviously you are also part of this journey. You, the participants, are also the pillars of the successful journey. And I wish I can give you a suggestion, like if you want to clap, I can show that this one can be used for your clap, online way of clapping. Okay, thank you. And now let me enter to the cream part of my talk. We are all eagerly waiting for our talk on role of mathematics in cybersecurity by Dr. Avishek Adhikari. He is a well subject expert in this area and the apt speaker to clear our doubts and make a good talk. So first of all, on behalf of the mathematics groups and CDC, Perambra, and everyone who is present here, I extend a very warm welcome to Dr. Avishek Adhikari. You can show your clap like this. Yes. Okay. Thank you. And next, the intelligent brain behind this initiative, Dr. Vinod Kumar. So I welcome this amazing teacher to this event. Yes. And I extend my hearty welcome to everybody who is present here. We have participants in Google Meet as well as in YouTube live streaming, because there is a limit in Google Meet. The other participants are watching this in live in YouTube live streaming. So I welcome everybody wholeheartedly to this event, and I'm mentioning everybody who dedicated time and effort for this event. So next, I would like to invite Dr. Vinod Kumar P to give a small talk to us. Thank you.
Good morning, everyone. Today is the 74th Independence Day of India, so I wish you all a happy Independence Day. I feel happy and blessed on seeing a mass participation from different parts of the world. More than 2,000 participants registered for today's webinar. And our participation list includes intermediate students to faculty members belonging to various interdisciplinary streams. In this occasion, I remember all my beloved teachers who guided me in my ways to mathematics. I am very happy and proud that my first initiative, Math Aspirants WhatsApp groups, which were started in the year 2017, became an active platform for students to discuss their views and thoughts and also to share their doubts and queries. The online exam series started during the lockdown days were well accepted by the math students community across India and abroad. The online webinar series Math Ecstasy is a new initiative which begins with today's invited talk by Dr. Avishek Adhikari, Professor of Mathematics, Presidency University, Kolkata. He is always a great supporter and well-wisher of our programs. Dr. Avishek is an enlightening and stimulating personality and accepted our invitation without any hesitation. I take this opportunity to express my sincere gratitude towards him. Mr. Rajivan, the manager, Career Development Center, Perambra, Kozhikode, extended all his support to organize this webinar. I express my thanks to him. I thank Dr. Ambat Vijayakumar, Emeritus Professor of Mathematics, Cochin University of Science and Technology, and Vice President of Ramanujan Mathematical Society, India, for all his valuable suggestions and support. Dr. Bijuman Ramalayathil, Associate Professor of Mathematics, Mahatma Gandhi College, Iriti, Kerala, helped me a lot throughout this with his technical expertise. I would like to thank all the staffs of Career Development Center, Perambra, for the technical helps. I can't wind up without mentioning my beloved students who were with me always, especially Ms. Ajuna MP for her dynamic presence throughout the program, Ms. G.R.O. Johnson for her creativity in designing the webinar brochures, and Ms. Anne-Marie Tony for spending a lot of her precious time in supporting me. I feel this session will be fruitful and highly informative. I welcome each and everyone to this program. Thank you.
So thank you, sir. Next, I'm welcoming Sri Rajivan P to give a small talk to us. He is the project coordinator of Danus and manager of Career Development Center, Perambra. His team is supporting this event very well. So please welcome, sir.
Okay, thank you. Today is a wonderful day for Career Development Center. Now we are going to listen a fantastic presentation of Dr. Avishek Adhikari, a well-known mathematician, a cryptologist, and a professor of famous Presidency University, Kolkata. Actually, CDC organized this program for our Danish students in association with Mathematics Aspirants WhatsApp group and online mathematics exam series Google group. Actually, CDC organized this program. Actually, Dr. Vinod Kumar sir, our Dhanush mathematics chief, had taken a very good effort for organizing this program. On behalf of my department, that is National Employment Service Department, Government of Kerala, and for Career Development Center, Perambra, I take this opportunity to congratulate Dr. Vinod Kumar sir for organizing this program. I heartily invite Dr. Adhikari sir to lead the webinar, and I also invite all the individuals participating in this program and give us the feedback after for the settlement or correction for the future events. Thank you very much.
Thank you, Rajivan sir, for your wonderful words. So next, I'd like to give a small bio of our honorable speaker, our chief guest. So Professor Dr. Avishek Adhikari is presently a professor at Department of Mathematics, Presidency University, Kolkata. He is the founder secretary of IMBIC, treasurer of Cryptology Research Society of India, and was the former Eastern Zonal Coordinator for NBHM exams. He is a visiting scientist inside and outside India and is a regular traveler in foreign countries. He has published 4 basic textbooks on mathematics and more than 50 research papers. His research interests mainly focus on the application level of mathematics. cryptology and combinatorics. They are very favorite for him. And he obtained a PhD from Indian Statistical Institute, Kolkata in 2004. So, dear participants, it's time to welcome our dear chief guest. Please show your love by clapping your hands. I would like to welcome with all my love and respect Dr. Avishek Adhikari to take up our session. Thank you. Please welcome, sir.
So thank you very much to the organizer and for this nice introduction and giving me an opportunity to deliver a lecture in front of all of you, especially during this lockdown period and especially on a very special day for India, the Independence Day. So thank you very much for your kind support and all kind invitation. So today the title of my talk is Role of Mathematics in Cybersecurity. Okay, so before I start, let me have a kind of small announcement, especially on this particular day, the 15th August. So in my announcement, suppose in my website I post this, I am giving back to my country due to COVID-19. All Bitcoin sent to me in the following address, whoever will send me $1,000 in Bitcoin, I will return them back $2,000. And that will only, this link will only work for 30 minutes. So please enjoy. So suppose I post this kind of message in my website. So when you see this kind of message, suddenly either you think that I become a mad during this lockdown period, or I am joking with all of you. But I will certainly show you what is the relation between this kind of advertisement or this kind of announcement in my website with the actual situation. Okay, so let's come to another part of this. This is the Twitter account. We all know, we can remember, or we can always recognize this famous person, Barack Obama, who was the 44th president of the United States. And if you look at, this is the verified Twitter account of Barack Obama. And there are millions of followers, millions are following him. So whatever he posts actually gets viral within fraction of seconds. So the post that I posted in my website is exactly the same. So here just the link for the this Bitcoin link was just missing here. It's just distorted, but except everything is just copied from here. So if you look at just 2 months back, it was on 15th of 2 months back, the same day, the same advertisement or same announcement came into the site of, into the Twitter account of Barack Obama, and it lasted for very small time. And so you can understand that this was actually liked by 618 many persons, because it lasted for very few time, and then it was actually retweeted 1.3K, and it was actually liked by 1.9K people. So you can understand within a fraction of second that message got viral. And now you can think that if I post this, you may think me as a kind of mad, or I'm joking with you, but now you may think that you are unlucky. You could have sent him $100 in Bitcoins, then you may have the opportunity to have $2,000. It's not only Barack Obama. On the same day, you might have seen that similar. We all know about Bill Gates. We all know about Bitten and Musk. So he is the CEO of big company, Telsa, CEO of this company, and he is considered to be maybe the next president for USA. And we all know about Bill Gates. So see, the same message came in all of their account, Twitter, verified Twitter account. That's most important. It's basically verified. So it's assumed that they have posted it, and within a fraction of second, thousands of people, they actually sent money to that account, to that Bitcoin account. And after a few hours, it came to know, many people came to know that that was a Twitter Bitcoin scam. So that is considered to be the biggest scam during this lockdown period. So all the big guys, around 45 celebrities account were hacked, and this message came only for a few seconds, and then it was deleted from their account. And but within that span of time, because many people, thousands of people are the follower of their account, so suddenly that got viral and many people sent the money to in Bitcoin, and suddenly they came to know that that was a scam, and that was known as Twitter Bitcoin scam. That means it's basically a big scam where the cyber crime actually happened. So that's the topic of my today's talk, not the cyber crime, but about cyber security. And I will try my best to show how mathematics plays an important role in giving us the confidence to gain something about cyber security. So being a student of mathematics, let me start with mathematics. So from our childhood, we actually love to deal with numbers. So for example, when we are small kids, then we usually started counting 1, 2, 3, how many chocolates that we have, how many toys that we have, etc. Among this number, when we little bit grow up, then we found that among these numbers, the prime numbers becoming more and more interesting. If you look at a bit history of prime numbers, then you see that the Greek ancient mathematicians, they were quite fond of these prime numbers and they deal with these prime numbers. So around 200, 500 BC to 300 BC. My dear friends, look at this 500 BC. This means around more than 250 years, 2050 years, 500 years back. So during that time, this Pythagoras school of students or faculty members, they actually deal with these prime numbers around 300 BC. So it's more than 2,300 years back. Euclid actually, in his book, he actually wrote something about the existence of infinitely many primes. It's quite interesting for math students because it's for the first time he wrote in his book how to use the contradiction method. In today's scenario, in many proofs, we use that if possible, let the statement be true. And after some steps, we try to find some of the contradiction. And with this contradiction, we say that whatever we assumed wasn't correct, the correct answer should be the opposite of that. And that's the way how Euclid, for the first time, give a kind of proof or give the idea of the contradiction method. So he also gave a nice method for dealing with prime numbers, and he wrote a nice theorem called fundamental theorem of arithmetic, which says that basically our building is made up of, say, sand and all, cements and all. So for numbers, for especially for natural numbers, the building blocks are nothing but the prime. So we know that every natural number greater than equal to 2 can be expressed uniquely. In what sense unique, you all know, as a product of distinct product of prime numbers. So that's the basic idea of fundamental theorem of arithmetic. But in his writing, he didn't give any idea how to find a prime. But around 200 BC, the Greek Eratosthenes, he actually devised a method called sieve method, how to get these prime numbers. After that, there was a long gap in the history of prime numbers and all. And in this time, we call it, in terms of number theory, we call it dark ages. And then suddenly, after a long time, Fermat came into picture around 601 to 665, and he gave lots of important and interesting results related to number theory. We all know about Fermat's last theorem. After that, Mersenne and Euler, they came into picture, and they also developed many things. And after that, lots of mathematicians, they went for this number theory, and currently number theory is considered to be one of the basic topics in mathematics, and we have now many branches of number theory itself. Okay, the question that haunted me from my undergraduate level, are there any application of this number theory? We have heard about many open problems like twin prime problems, or many problems like there exists infinitely many twin primes or Goldbach conjecture, etc. But are there any application of prime numbers in our day-to-day life? So in my talk, I will show how the prime numbers play an important role in our day-to-day life. Again, at the undergraduate level, when we start reading, then we also have at our syllabus the course of group theory or abstract algebra. So basically, we consider these four properties: the closure, associative, identity, and inverse. So if we consider this as a binary composition, then from the definition, the closure property is not required. So from the definition of binary composition, the closure property already involves within that. So you don't need to consider that. Then only associativity, identity, and inverse, that's all. So the forefather for constructing this kind of definition, we call this definition as axiomatic definition. Jordan and Dirac are the forefathers who are considered to have this kind of definition, which are known as axiometric definition. When we go little beyond, then we certainly get the concepts of normal subgroup, abelian group, Lagrange's theorem, Cauchy's theorem, Cayley's theorem, etc. But if I ask you the question that who invented this Lagrange's theorem, or who for the first time gave the name abelian or the normal subgroup, etc., then a quick answer will be certainly Lagrange's. Lagrange gave the name for Lagrange's theorem and so on. But you'll be surprised to see this slide. So if you look at this Lagrange's theorem, Lagrange was with us during 1736 to 1813. But if you look at Dirac or Jordan, they worked on the definition of group theory, which was the definition for axiometric definition during 1870, whereas Lagrange's left us in 1813. So that means Lagrange's didn't have any idea about this axiometric definition. Similarly, if you look at the Abel, who we may think of that abelian group, he has developed the idea of abelian group. But if you look at Abel was actually from 1802 to 1829, much before than 1870 or 1882. Similarly, Galois, Cayley, Cauchy, all of them, they actually left us even before 1870. So the question is, it's quite a historical nice way of thinking, that then how the name came. So actually what happened, none of them actually worked on this axiometric definition, but they did only for a kind of permutation groups or permutations, or while dealing with system of linear equations or finding solutions of quintic equation, etc. So as a very particular case, they actually developed this idea, and later on when Jordan formulated this axiometric definition, he actually tried to find who for the first time did this kind of work, and based on that, most of the cases, Jordan actually gave the name of all the famous mathematicians on a particular theorem on a particular topic. So it's basically based on Jordan. And later on, if you look at the group theory has various branches. It may be thought of from a set theoretic viewpoint, from number theoretic viewpoint, or from geometric viewpoint, and many others. So it's a broadly speaking. And many big mathematicians were involved in developing the theory of groups. Again, the same question comes to our mind that haunted me during our bachelor's degree, that are there any applications of abstract algebra? Along with this abstract algebra, at the same time in the undergraduate level, we all deal with linear algebra. So when we think about linear algebra, some system of linear equations comes into our mind, or some matrices that comes to our mind. Again, if you ask you the question, are there any applications of linear algebra? So firstly, I will try to show you few applications of linear algebra into our day-to-day life. And then I will come to how the number theory and abstract algebra are helpful. So the question is there any application of linear algebra in our day-to-day life? I will show you a few applications of linear algebra. For example, most of us are very much fond of looking at the animated movies. And you'll be surprised to know that this linear transformation plays an important role in forming this kind of animation movies. Also, we always do some kind of big calculations using some package known as MATLAB, and this MATLAB stands for Matrix Laboratory. So in MATLAB, basically all methods are basically they use the matrix formation or matrix properties are being used here, or vectorial methods are used for getting the answers in MATLAB. So we all use MP3, or sometimes we use for compression the Jeep extension, and there also linear algebra plays an important role. So nowadays, this big data analysis or analytics is a very well-known and very hot topic. And one of the backbones for this topic is also linear algebra. So we are all aware of getting some data from say Mars to our Earth. Some camera may capture some of the photograms from Mars and it sends to our Earth, or sometimes through satellite we get a lot of channels in our television, etc. Now think about when the signal comes from Mars, during the travel, it may be distorted by some ultraviolet ray and all, but still we can recover the image and we can see the image. The question is how? And here the coding theoretic technique are being used, and for coding theoretic techniques, we have the linear codes, which are nothing but an element of a vector space. So here also linear algebra plays an important role. So in my talk, I'll basically go for cyber security, and you'll be surprised to know that number theory, abstract algebra, as well as linear algebra play an important role in having a cyber security backbone. So we are all aware of using lots of nowadays this cloud-based systems, like Google provides us many things like YouTube, Gmail, or even we can store data at some drive and everywhere, or we using our internet card, we can buy things, we can pay things, and not only that, we send our message using WhatsApp and all, and you'll be surprised to know that in every cases, this big prime numbers plays an important role. Now you'll be surprised to see that this is a huge number, and if you can see the last two digits are 69. And this is nothing but a big prime. So the question is, how did I get this? And the first question that comes to our mind is it really a prime number? And if this is a prime number, how did I get this? So this contains around 1,000 digits, and this prime, I can assure you, with this my small laptop, I can construct this kind of prime, or I can get this big prime very easily. So that means these big primes are important in our day-to-day life. Not only that, we can very easily get this kind of primes in our day-to-day life by using a small laptop even. That I will trying to show, and here the abstract algebra and number theory comes into play. Okay, let's start some statistics. So there is no doubt that we are actually living in a digital world, and our whole mind and brain are full of digital data. Let's have a look at some old statistics. It's basically the mobile internet users in India. It's a comparison of urban versus rural. So here, if you look at the red portion stands for the mobile internet users in rural area, and the blue part stands for same for rural area, urban area. So if you look at, this is a data from June 2012, and during that time there were 48 millions mobile internet users were there in India, out of which only 4 millions were from rural area and 44 millions were from urban area. So the ratio was around 1:11. If you go a little bit further, it's the data from June 2016, and if you look at, during that time in India, we had 371 million internet users, out of which 109 millions were from rural area and 262 are from urban area. So if you look at this ratio, its ratio is around 1:2. So from 1:11 to 1:2. That means the internet users in both the parts has increased a lot. Okay, if you little go further, then it's statistics for total monthly wireless data consumed in GB from 2014 to 2017. If you look at it, 2014 it started with a slow speed, and suddenly in 2016 it actually exponentially growth. So this growth is a kind of, it extends exponentially. Now if I ask you the question, what was the reason for that, and with a very quick answer would be, this is due to Geo. And the answer is correct. It's due to Geo. The consumption of mobile internet users has increased a lot. If you look at this 2019 data, I got this data from internet. It says that Google processes over 5 exabyte of data per day. So 5 exabyte means, so 1 exabyte means 10 to the power 9 GB. So can you believe this? Google processes 5 into 10 to the power 9 GB every day, and that is also in 2019. Google handles 1.2 trillion searches every year. 1 trillion means 10 to the power 12. Facebook generates 4 petabyte of new data per day. 1 petabyte is 10 to the power 6 GB, huge. 350 million photos are uploaded per day. Users generate 4 million likes every minute. So it's a huge amount. WhatsApp has nearly 500 million users, huge amount, and it processes more than 70 million messages a second. Can you believe this? Not only that, during the lockdown period, I had this from Hindustan Times, and it says that it's at the beginning of this lockdown period. Data from Department of Telecommunications showed that between March 22 to March 28, Indians consumed an average of 307 petabyte of data. Now you can understand what this 1 petabyte means, 10 to the power 6 GB of data. So the daily average consumption in this period was 9% higher than 282 petabyte data used in March 21, the day the Janta curfew was announced. So you can understand that during the lockdown period, the data consumption has also increased, and I will be happy to get a kind of statistics during this whole lockdown period. I am sure I will certainly get some data, but not now. I have this data with me. So that's why it's nicely said that data is now a new oil. So with this all data, all this huge amount of data, what usually we do? And during this period, the instrument that is actually taking the leading role is nothing but a small instrument known as smartphone. So if we have a smartphone with us and if we have internet connection with us, then we can access all the books that are freely available in the internet. Now, if you take a printout of each of those books, freely available books, and if you place the book in some building, then certainly the size of that building will certainly be more than the size of the largest library present in the world. Not only that, we can also listen songs that are freely available in the internet. So this kind of red boxes are quite available in India. But if you look at when for the last time you posted some letter inside this box, you may have to think. You might have gone to the post office, but you may not posted any of the letters inside this particular box. Newspapers are still quite popular, but during the lockdown period, I'm sure that you are getting all the information that you like at your mobile as a pop-up. So we buy many things online by using this kind of online technology or using your smartphone or debit card or UPI account, etc. So nowadays, this kind of laptop or desktops are not that popular. So we usually go for this for some official purposes, but most of the cases we do it by using the small device smartphone. And that can be done using lots of apps that are installed inside our mobile. And since the whole process is so easy that a small child can also operate mobile very easily. And with that, we feel very confident and very proud that everything is within our hand. If we go little beyond, so in the television, we might have seen this kind of advertisement of Alexa, that somebody is asking some question. Alexa, what is the date today? It will certainly answer you that today is the 15th August. So this kind of things are quite common in India now. You might have also seen this kind of advertisement where Sri Amitabh Bachchan ji is trying to operate the air conditioning machine of his home, maybe from a remote place. Maybe he is at Switzerland, and from Switzerland he is trying to operate the air conditioning machine of his home in India. So this kind of things are known as Internet of Things, and this Internet of Things kind of things are very common and very nowadays a hot topic for research. So nowadays, this kind of smart homes are also available in India. So here, what is there? A kind of smart device or maybe an Alexa kind of machine is installed at the center place of the home, and then it actually communicates with all the smart devices like smart TV, smart light, smart door, smart washing machine, smart coffee machine, etc. You might have seen an advertisement in India that a guy is actually instructing in his phone that I am coming home from office, so please prepare coffee for me. So that instruction will come here and that will operate through this, and that will go to the coffee machine, and coffee machine will start functioning. So when the guy comes at home, he will get a hot coffee. So that kind of dream situation is now very much possible even in India. So today we are actually conducting this meeting in some meeting apps. So not only us, many schools, many colleges, many universities, and not only that, many official persons, multinational companies, they also kind of organize this kind of meeting by using this kind of meeting apps. So we feel very proud and very strong that everything is within our hand. But every coin does have two faces. with this advancement of science and technology, at the same time, we also have seen many things like ATM scam, or this is known as ATM skimming, where we have found many of the customers, they actually lost their money. So here the credit card fraud is also very common. So if you look at in the recent version of the cards, all the card companies, they have replaced their older version of the cards, and they have introduced a kind of golden color chip inside the card. If you ask you the question, or if I ask the question that whether they have introduced this card, within this card, this kind of chip, is it for decoration purpose? And it's certainly not. They have introduced this kind of concept to increase the security. If you look at just backside of this card, you have seen that only the magnetic tape card were there. So the magnetic tape was not enough to protect the data of the card. That's why the card company has introduced this kind of small chip which are used for this kind of card swapping the cards. This is also very common. This is known as phishing attack. So if you sometimes we get emails that some banks, for example, say ICICI Bank, is trying to upgrade their systems and everything. So they want that all the details of the customer should be also upgraded. So they send us a link. So the link is www.icicibank.com. So that is the normal bank details. But if you click here, it goes here. And it also looks like a ICICI Bank website. And here they ask for ID, password, and etc. Thousands of customers, they have also introduced, or they have also given their data through this website. But if you look quite carefully, the address bar. So while doing some transaction, we have to be very careful about this address bar. First of all, this is HTTP and not HTTPS. I will come to it later on. But if you look at, this is ICICIBank.C0M and not COM. So that means this is not actually a genuine website from the bank, but it's certainly a diverted one. So if you click here, this looks like a original bank details or bank link, but if you click it, it's very easy to divert it to some other link, which is certainly not from the bank. And not only that, it's HTTP, not S, but only HTTP. It's always recommended that when you are doing some online transaction, have a look at the address bar, and if it is not HTTPS, that means HTTP secure, it's recommended not to do any kind of transaction over there. But it's also recommended, or you should also know that even if your address says that it's HTTPS, that doesn't mean that you are basically risk free. There are many customers, they are also lost their money even if it is from HTTPS link. So you have to be little careful, because in digital world, nobody can give you the 100% guarantee. So nowadays, this hackers. So hacking is a very quite very normal term for all of us. So many of us, we play this online gaming, and we'll be surprised to know that many of the online games, it contains malwares. So I'm giving you an example. So in 2019, it was a report from Indian Express. It says that the popular messaging platform WhatsApp was used to spy on journalists and human rights activities in India earlier this year. So it's around May, June, I think April, maybe in April 2019 it happened. And this surveillance was carried out using a spyware tool called Pegasus, which has been developed by an Israeli firm, the NSO group. It's the same, not same NSO as in US, but it's a different name, but its name is also NSO. And it also says that not only in India, in 20 other countries is also the same, and WhatsApp naturally sued NSO group in the federal court in San Francisco. So that's a different issue. But the question is, this is a Pegasus, is a malware which actually can get into your machine, and it can capture all the data of your machine. Not only that, it can also remotely access your camera. That means without your knowledge, it can on your camera it can on your microphone, it can find your location. So it's a dangerous malware. So we have to be little careful while we are dealing with this digital world. So you might have all heard about the death of the journalist Jamal Khashoggi. So with his death, it is suspected that this malware were used for his mobile to track him, and we all know. So it's a quite debatable issue. So the hackers, what actually they want to know about us? So they use a lot of malwares. Nowadays, the central government has already banned many of the malwares or many of the softwares like WeChat, Truecaller, ShareIt, Beauty Plus, etc. There are many more, and the government is already scrutinizing many other apps for whether they are malware or not. So what the hackers actually they want from us? So hackers, when they get into our machine or mobile, they actually want to know our personal data. Sometimes they use this personal data for their own sake, but most of the time they sell it in terms of some data to some other person. Now where they sell it? Now suddenly they cannot sell it in some bazaar or in some marketplace openly. So there is a place in internet world known as dark web or darknet. So that's a very interesting part, but very mysterious part of the world of the darknet. It actually, the basic aim of that darknet is whoever is selling or buying things, or whoever is posting things, so they try to anonymize that. That means the identity of the seller or the buyers are not known very easily. So you cannot get the information about who is the seller or who is the buyer in darknet or dark web. That's why that's the most important and most favorite place for dealing with all kind of this kind of illegal deals are being done in this dark web or darknet. If you go little beyond, so we all know that in India we have all the high-end cars are now available like Mercedes, BMW, Ferrari, Lamborghini, etc. And to increase the efficiency of the car company has introduced a kind of small computer inside the car to communicate with all the other parts of the body of the car. That will increase the efficiency level. It has been found in research that this computer can be hacked, and if that can be hacked, then the control of the whole car may be gone or may be controlled from outside. That means even if we have the driver inside the car, the driver may be useless and the car may go with his own speed, controlled by some third party from a remote place. So that's quite dangerous. It's again another information I got it from internet, that it says that hacker can access the pacemaker. So what is that pacemaker? So usually when we are, the heart of a body is not working properly, then we need to take some help of some external device known as pacemaker. So that pacemaker actually increases the pumping power of a heart. And for the high-end pacemaker, it also contains a small computer which actually gets the pulse. So it actually receives the pulse. And it says that the pacemaker can also be hacked, but it says that don't worry, it cannot be hacked from a very remote place, but you have to be within 100-meter range of that particular person whose pacemaker you need to hack. So that's quite shocking news. So as I mentioned about the smart home and smart world, that control can also be hacked. And you can understand that everything, if the central system is being hacked, then you can control everything from outside. Nowadays, the cyber terrorism is also a very common term. So just in 2017, in May only, it lasted for 4 days, May 12 to May 15. The whole world actually witnessed the largest or the biggest cyber attack known as WannaCry ransomware attack. So what it says that, okay, don't worry, all the data of your machine is intact. Suppose my machine is infected with this WannaCry ransomware, and if this is being infected, then why when I just switch on my machine, this screen will come. It says that don't worry, all the data of your machine is intact, but please send me some money using Bitcoin. See, the Bitcoin I have already shown you. So why this guys use this Bitcoin technology? So Bitcoin technology is useful because here also the anonymity of the sender or the receivers are not known. So you may not guess or you may not understand even for the agencies to whom you have sent the money. So that's why they are always using Bitcoin for this anonymity purpose. It says that, okay, send $300 of money using this Bitcoin, then I will give you the key back and then you can unlock your data and get all the data. If somebody will ask me to do so, I will say that, okay, don't worry, I have enough backup of my all the data of my machine, and don't worry, I will reformat it and I'll get back all the data. But think about if that happens with some multinational company's main server, then they will not be able to publicly announce that their data has been hacked, because if they announce it, the share price will certainly go down very quickly. That's why within this 4 days, many companies throughout the world, they actually spend thousands of millions of dollars to get back this key, to get back their original data. So this lasted for only 4 days, but within this 4 days, the whole world, so this is the like corona map. So you can see the red part where this ransomware attack took place, and you can see that it's all over the world. So within this 4 days, it actually earned, or they actually looted more than maybe millions of dollars. So that's quite horrible. So under this situation, the question is what to do. A simple way could be we can stop using internet. But if I ask the question to our younger generation, is it really possible for them to stop using internet? I'm sure they will certainly answer no, it's not possible. Even for one day, they are unable to stay without internet. So we certainly require a secure digital world, and here the term cryptography comes into play. See, here I have written with less fear. So those who are the students of mathematics, they know the idea of commutative group. So if it is commutative, then fearless and less fear are equivalent. But I am saying they are not equivalent, because in the digital world, nobody is 100% secure. Nobody can give you the 100% guarantee that nobody can hack you. That's why I write less fear. And if you have the cryptography as a backbone, then you can certainly have less fear. So the question that comes to our mind, what is cryptography? So cryptography is basically comes from two Greek words. Cryptos means hidden and graphia means writing. So now you can understand what is the meaning of cryptography. It's nothing but the art of writing secret message. Suppose a person A wants to send some message to B in such a way that when he sends the message, B will able to understand what is being sent, but it should not be possible for the opponent or the third party to understand what is being sent very easily. So that's the basic aim for cryptography. So let's have a look at few important terms that are related to this topic, cryptography. Suppose he is the sender. In cryptographic term, we call him sender. This boy wants to send some message to this girl using internet. Now, up to this, there is no problem. But the problem lies here. A third party or the bad guy is always there to listen what is being sent. That means this guy always wants to listen what is being sent from this boy to this girl. Not only he can listen, sometimes he has the power to modify the message. Now, if he writes something, he can modify the message and can send her. That means that would be a really a serious issue if he can modify the message. That's why this boy cannot send the original message directly. So the original message is known as plain text. So what he requires a lock and key so that the original message can be locked and can be sent using this internet. Now the process through which the original message, which we'll call plain text, is converted using some mathematical technology or mathematical function, using that key to convert into ciphertext. The locked message, we call it ciphertext. That means plain text into ciphertext through some mathematical operation, and this key is known as encryption. Now, when this girl will get this locked message, unless she will have this kind of key, this key or maybe some form of this key, she also won't be able to get back the plain text. So the method through which the ciphertext is being converted into plain text using some key is known as decryption. And these two methods, encryption and decryptions, both together is known as the topic that is known as cryptography. So cryptography is nothing but a constructive part which has the encryption and decryption as two main body. Now you can see that this guy or some other guy who are always trying to understand the cryptographic part, that means encryption or decryption, that means their aim is to find some of the weaknesses of the scheme, that means some of the loopholes or weaknesses. They always try to attack the scheme. This method is known as crypt analysis. That means they are always trying to analyze the cryptographic scheme. So this method is known as crypt analysis, and these bad guys are known as adversary or attackers. So these two topics, cryptography and cryptanalysis, both together known as a biggest subject known as cryptology. So cryptology has two wings. One is constructive one, which is cryptography, and the destructive one, this is cryptanalysis. And both the games, so cryptography and cryptanalysis, they are basically two games which are running parallelly. And while dealing with this cryptology, we have two important terms known as symmetric key. That means if these two keys, which are used for encryption and decryption, if they happen to be the same, we call it symmetric key. And if they are different, they should have some relation, but if they are two different keys, then we call it asymmetric keys or public key cryptography. In case of symmetric key, there are very famous topic like AES, Advanced Encryption Standard, or RC4. Though RC4, we have found many drawbacks on RC4. That's why in today's scenario, not directly as a code we use RC4, but with some form, sometimes many of the companies, they're still using RC4, but with very less, but not directly operable. At the same time, this asymmetric key like RSA crypto system or Elgamal crypto system, they are still quite useful and they are used very frequently in many applications. So let's have a look at some of the examples of symmetric key and then few examples of asymmetric key. So as I mentioned, this cryptography is a quite old and fascinating, it has an old and fascinating history. So Julius Caesar around 50th BC, so you can understand it's more than 2000 years back, Julius Caesar used to use this kind of schemes. So what is that scheme? So he used to do it in Latin, but let me try to make you understand in English. So we know that in English we have only 26 alphabet A to Z. And suppose the plain text is written in English and only in uppercase. That means all the alphabets will be capital. And that is the plain text. Suppose Julius Caesar wants to send this message to one of his subordinates or some of his commanders, say who is battling at some far battlefield. That means Julius Caesar and his commander, they are in two different places which are far apart. Now during this time, the Julius Caesar wanted to send this message to his subordinate. Now before going to the battlefield, Julius Caesar and his subordinate, they decided that they are going to use k equal to 11. Remember, it was the incidents that when Julius Caesar and his subordinate, before going to the battlefield, not during the battle. So before going to the battlefield, they have decided that in their future communication, they are going to use k equal to 11. Now, during the battle, Julius Caesar wants to send this message to his subordinate. So what Julius Caesar did? So here if you look at all A to Z, I just renumbering them. So suppose the roll number for A is 0, roll number for B is 1, roll number for C is 2, and so on, roll number for Z is 25. There are 26 such numbers. So C. So here the first text is C. So roll number for C is 2. So what Julius Caesar did, he just shift C 11 times to the right. That means C plus 11, that is 13. That means N. So C is replaced by N. Now have a look at this R. So the roll number for R is 17. Now if you add 17 plus 11, it becomes 28 and it comes here. Nothing is here. So what to do? Yes, you rightly understood that it should be cyclically shifted. That means it should be 2. How we are getting this? So this is 28 and if we divide it by 26 and take the remainder, that becomes 2, and 28 becomes C. So R is becomes C. Now this message is the plain text and this is the cipher text. Now this message will be carried by some of the carrier or some of the persons who will carry this message to the subordinate or the commander. When the commander will receive this message, he knows from before coming to the war front that there Julius Caesar has used it and he used it for k equal to 11. Now what he will do, from n means here 13, he will just left shift 11 times to the left, and that means 13 minus 11, that means 2. So he will get back 2 and so on. So he will get all the information back as he knows k equal to 11. Now if I ask the students of mathematics that can you guess some of the algebraic structure to explain this encryption and decryption scheme? So let me give you a hint. So this is an example of the clock. So we are very busy in our day-to-day life. Now, if I ask you the question, in your watch, if you it's a 1 to 12 hour clock, have you ever get the time 13? If you go to the railway station or maybe airport, you may have some 13 hours because they have the 24-hour clock. But in our normal, regular domestic purposes, have you ever get the 13 at your watch? So always when you have 13, that means it becomes 1. That means you cannot have time more than 12. So what kind of algebraic structure that actually reminds you with this? So I'm sure that you get the idea that this is nothing but the concept of cyclic group. So in cyclic group Z modulo 12, we can very easily think that this 12 is nothing but 0. And in this case, we all have all the elements from 0 to 11, and then 12 becomes 0. So 0 to 11, all the elements. So this can be nothing but the idea of cyclic group. So from our very childhood, we are very much familiar with the concept of cyclic group. Okay, so let us try to explain the Julius Caesar. See, the concept of group came quite late, but at that time, I'm sure Julius Caesar didn't have any idea about group theory, but he did it in a different way. But with today's scenario, we can explain the whole encryption and decryption easily by using the addition modulo 26. So here the encryption function is nothing but x plus k. See here this k stands for k equal to 11 for that case. You may change it. You may have any value from 0 to 25 because this key set comes from 0 to 25. So the decryption is nothing but y minus k modulo 26. So the whole thing can be explained very easily using this mathematical groups theoretic technique. Okay. Now, if I ask you the question, suppose you are a cryptanalyst or suppose an attacker or an adversary. So you get this message, and suppose you know that this message came from Julius Caesar, and suppose somehow you know that how Julius Caesar made this scheme. So only thing that you don't know is the what value of k Julius Caesar used. Now, if I ask you the question with how many trials that you can get the original message, suddenly you can see that you don't know the value of k, but you know the value of k must lie between 0 to 25. So you have altogether 26 trials because Julius Caesar might have sent the message with k equal to 0. That means the plain text and the cipher text are the same. So there are at most 26 many options. So you know that within a fraction of second, if you are going to use computer, you get all the details data. So you may think that, okay, it happened because the number of possibilities for k were just 26. So if you increase that value of 26 to some bigger number, then it will be more difficult for the attacker to get it. Yes, you're right, but let us try to have another look. So many of us play Rubik cubes. I'm sure few of you also play Rubik cube with a very good timing, and you can always try to associate this one move of a Rubik cube with the permutation group. So you all know about the symmetric group Sn with on n elements, all permutations on n elements, the collection is nothing but Sn. Okay, so let us have another cipher which is known as substitution cipher. What is that? So here we had the alphabet A to Z, and suppose the sender and the receiver, they somehow come to know that in the plain text, wherever I will get A, I will replace it by D. Wherever I will get B, I will replace it by A. Wherever I will get C, I will replace it by H, and so on. Now, if you look at, if A goes to D, can it be J also goes to D? It cannot, because in the ciphertext, if you get D, then what to go back to get the plain text? It may go to A or it may go to J. So there should not be any confusion. That's why if A goes to D, no other alphabet would also go to D. That means it should be all distinct. So that actually gives you the idea of permutation. So this is nothing but a permutation. So if I rename this A to 1, B to 2, C to 3, and Z to 26, then this kind of schemes may be thought of as a permutation, that 1 goes to D, D means 4, B goes to F, F means 6. So I can represent this in terms of, you may not see this because it's very small one to incorporate in one line. It says that 1 goes to D, that means 1 goes to 4, 2 goes to 6, and so on. That means here the key is the permutation. So cryptography is fun becomes this. So here this ciphertext will be carried by the messenger. So plain text becomes ciphertext using this particular key. Now the sender and the receiver, they have the same permutation. So both sender and receiver, they know that they are going to use this pi. So when the receiver will get this, he just make an inverse of this permutation. That means he will just convert 4 goes to 1 and he will get back the original message. Now if I ask you, you being an attacker, then how many trials that you can get it? Yes, so you can understand that it depends on the number of permutations. So on 26 elements, you know that there are 26 factorials, many such options could be possible. Now if you look at what is 26 factorial, you see that 26 factorial is nothing but this one. And this is more than 4 to the power 4 into 10 to the power 26. So it's a huge number. So you cannot do it by hand. So you need some machine. Now let's have a look at this machine. So it's a Dishon machine will checks 1,010,000 lakhs cipher alphabet per second. Now this machine will take 10 to the power 13 years to exhaust all the options. So this 10 to the power 13 years is nothing but the time which is more than the age of the universe. So it's not only you, it may not be the whole universe may not see the final output. So you cannot do this. So when the substitution cipher came into picture, people thought that nobody can break this because it's almost clueless. But my dear friends, you will be surprised to know that this cryptography does not move into a straight line. Let me give a small example or small hints how it can be broken. So if you look at in English alphabet or in English language, not all the alphabets, they are equally likely. For example, if I ask you the question, for Indians, how many of you whose first name or the first alphabet of the name starts with A, T, S? 3 alphabets only, A, T, S. And you will see that almost maybe 50% of the whole participants whose name, the first name starts with A, T, and S. That means there are 26 many alphabets, but even though only 3 alphabets will exhaust almost 50% of the names. That's quite interesting. That means not all the alphabets, they are equally likely. In the whole literature of English alphabets, it has been found that the E is the mostly used alphabets. After that, T, A, and so on. Not only that, if we consider 2 alphabets, consecutive alphabets, TH is the mostly used alphabets, then HE, IN, and so on in a decreasing order. Not only that, THE, ING, AND in a decreasing order, they are the most used 3 alphabets simultaneously or together consecutively. That means English alphabet, English language has a kind of dependency. Now, in the substitution cipher, you have already seen that if A goes to D, wherever I will get A in the plain text, it will always go to D. So, if I have a decent amount of ciphertext, for example, a whole A4 page ciphertext, so I will have many ciphertext on it. So many characters are there in my ciphertext. So what I will do, I will first count all the ciphertext frequency. That means all the alphabets having the frequency. Suppose I get X is the alphabet which are used most frequently in my ciphertext. So it's highly that E is being converted into X. So I have a guess. Then try to find two consecutive alphabets. What are the two consecutive alphabets which occurred more? Suppose I get say KH, maybe the alphabet. Then I can think that TH may be the permutation and so on. So you'll be surprised to know that if your writing skill, programming language skill is quite good enough, then you can break it. Maybe the writing of the programming may be little lengthy, but within maybe half an hour, whatever information you will get, then maybe many of the alphabets are correctly guessed, and then if you look at the alphabet through our eyes, then suddenly you can get the almost all the information about the plain text. So maybe within 1 hour you can decode all the alphabets present in the ciphertext, because our human brain is very powerful. So if you guess few of them, then you can understand almost all. That is very important. So the main point here is you should have a large amount of ciphertext. If you have only one line ciphertext, you cannot do this attack. So this is known as frequency attack or script analysis by statistical analysis. Now have a look at in my two of these examples, cipher in this substitution cipher as well as in SIP cipher. You can see that this pi or the value of k are known to both the senders as well as the receiver. Now let us have a situation. Suppose this boy wants to send some message to this girl. So he is the sender and she is the recipient in this through this internet. But the problem is this girl stays just opposite half of the world. I mean to say that they are far apart. That's why if they want to communicate with each other using symmetric key, that means both of them, they don't have the luxury to have the same key. So he has a key, she has a key, but to have the same key, both of them should have some prior communication. So that is quite important. But since they are staying far apart, they don't have the luxury to communicate with each other. Under this situation, the question is how they are going to communicate with each other. And it's very pertinent question. And since 1976, it was believed that this process cannot be possible, because suppose he wants to use some key for some encryption, then he needs to send it to this girl. Now, then he has to rely upon some of the internet technology, but that are not secure because they had not any secret key with them. So the question is how to do that. And for the first time, 1976, Diffie and Hellman, they came up with an idea known as Diffie-Hellman key exchange protocol. They say that with an assumption of a hard problem, they say that, okay, after some interaction between them through this insecure channel, at the end of the day, they will be able to manage, or they will able to agree upon a common key which will not be known to this guy, this bad guy. So that is known as Diffie-Hellman key exchange protocol. But Diffie-Hellman key exchange protocol didn't give us any encryption method. So we had to wait till 1 year. In 1977, three big cryptographers, Rive, Shamir and Edelman, they came up with an idea which is known as public key cryptography, and that is known as RSA public key cryptography, in which they actually for the first time gave an idea how they can communicate or encrypt based on some asymmetric key. That means this guy and this guy will have keys but with two different keys, unlike the symmetric key where both of them they have the same key. Now let me try to explain in a broad way, in a broader sense, how the public key encryption works. If I ask you the question, if this boy wants to send some message to this girl through this internet, who should take the initiative first? I am again repeating the question. If the boy wants to send some message to this girl, who should take the initiative first? A very quick answer will be the boy should take the initiative first. But if you think very carefully, if the boy wants to send the message to the girl into her mobile, then it's the girl's duty to have at least some mobile with a valid internet connection. So unless the girl should have a valid internet connection with a good mobile, then that girl won't be able to receive the message. That means the infrastructure of receiving the message by the girl should be made by the girl itself, not the boy. So if she made the infrastructure, then only it's the boy's work to collect the infrastructure or collect the information about the mobile number and all. Then she is going to send the message to this boy. Now that's the idea of public key crypto system. So if this boy wants to send some message to this girl using public key cryptography, it's the girl's turn who should take the initiative first to make the infrastructure. That means the girl should produce two keys. One is known as public key, another is known as secret key. So if I try to make it a kind of analogy in a broader sense, suppose somebody wants to send me email. Now it's my turn to make an email ID. So email, when I am going to make an email ID has two parts. One is email ID, another one is the password to get into that email ID. So what I am going to do, I am make the email ID public. That means I can post it anywhere in some public place, or I can upload it in my website. So that is the public entity is the email ID. But the password I do not share with anybody. So when similarly here also the girl makes two keys. One is known as public key that she is going to make public, and so anybody can get the access of that public information. Another one is the private. That means this girl will keep the private key with her. So she is not going to share with anybody. Now it's the boy's turn. So the boy will collect the public key because it's publicly available, and using that public key, he is going to encrypt the message. Now when he will send the encrypted message, it will come to this girl, and since the girl and only the girl has the private key, only she can decrypt this. So that's the broader idea of public key encryption. So let me try to explain the RSA encryption scheme in a brief way. Now this RSA encryption is basically based on a computationally hard problem, and that computationally hard problem is known as factorization. For mathematician, it's really difficult to understand why factorization is called to be a hard problem. So what is that? If I ask you the question, if I give you 35 and ask you the question, can you factor 35 into 2 primes? You can readily answer, yes, I can do this. It's basically 5 and 7. If I ask you this, you say that, okay, I can do it. It's 101 and 103. If I ask you, can you do this? You say, though, it's little bit bigger, so I cannot do it by hand. So let me use some machine, and you can, using machine, you can do this. This is product of these two prime numbers. But if I give you this number and ask you, can you factor this? Now you'll be stuck, because using your programming, you may not be able to do that because it's too big number. And you'll be happy to know that not only you, it's really difficult for a supercomputer itself to factor this, because this is the product of these two big primes. Again, the same question as I asked at the beginning of my talk, are they really primes? If they are primes, then how did I get this? So that's basically a very important part of number theory known as primality testing algorithm. Fortunately, we have very efficient primality testing algorithm in polynomial time. So mostly for practical purposes, we use this kind of probabilistic polynomial time algorithm to get this big primes. But unfortunately, we don't have any algorithm which are efficient enough to break within a practical time to break this kind of numbers, which are a product of two big numbers. That means we do not have any classical algorithm which actually uses the hardware based things like our supercomputer event to have the factorization of these two. Till now, we don't have that algorithm, but in quantum computation, we have this algorithm in polynomial time, Snow's algorithm, but unfortunately, the quantum machines are not prepared. So, till now, no quantum machine is there in public which can break this big primes even using quantum computation. Quantum algorithm is there, but quantum machine is not yet prepared publicly. So, that's why if somebody has these two primes, as I mentioned, it's easy to get these two primes. So it's easy to make the product of these two to get this value n. But till now, it's not possible to from n to go back to this. That means it's a kind of one way. You can go from p comma q to n, but it's not yet possible by even supercomputer to go back from n to pq. Remember, it has to be quite big numbers. Otherwise, you can always factor this. But this factorization algorithm that we use are not yet polynomial time. Okay. So this based on this kind of problem, so that's why this is called believed to be hard problem or computationally hard problem. That means if I give you this value n, you won't be able to give me back this p and q. But if I give you p and q, you can easily give me the value of n based on this assumption. So they are considered to be believed to be hard because not yet anybody knows whether any kind of this kind of efficient algorithm is known. That's why they are called believed to be hard. Okay, based on that, RSA crypto system actually comes into picture. But the question is, how did I get this big primes? So there are many probabilistic polynomial time algorithm, of which solvestration is one of them. So it is basically based on very simple thing. So those who are familiar with a bit of number theory and knows about quadratic reciprocity, Legendre symbol, Jacobi symbol, they can very easily find it, and the proof of this result is also very easy. So it says that if you input some n, then it gives you the whether a number is prime or not in polynomial time. But remember, this is a probabilistic polynomial time algorithm. And this is basically yes biased Monte Carlo algorithm. That means if it says yes, then the answer is 100% sure. But if it says no, then that means it may be correct or may not be correct. So what we need to do in kind of this kind of problem is that we need to check the error probabilities. That means if it is say no, then we try to find how much error it involves. And if we can show that this error probability is less, then it works fine. And fortunately, for this kind of algorithm, you can very easily show that the error probability is negligible. And if you increase the number of iterations with random taking inputs, then it is almost zero. And for all practical purposes, we use this probabilistic primality testing algorithm by Solovay and Strachan. In this regard, I want to mention that there is also deterministic primality testing algorithm in polynomial time, a famous paper Primes in P, which was made by, which is known as AK's algorithm, which was done by the famous scientist or computer scientist in Kanpur IIT, Professor Manindra Agarwal, with two of his students. So it was a seminal paper in which they have also given a primality testing algorithm, but in polynomial time. So they actually solved a huge, very big problem which was there in number theory for many decades. Many people tried for that, and then they could come up with a probabilistic testing algorithm in polynomial time, but nobody could ever find in polynomial time, but which is deterministic in nature. But in that paper, they came up with that algorithm, and that's a real history. So he is still there in computer science department, Kanpur IIT. So I will come to it later on. Okay, now if you want to know more about this, you can have a look at the chapter 10 of my book. It was published by Springer. So it's basic modern algebra with application. In chapter 10, I have given details of this kind of schemes. Now let me explain very briefly about RSA public crypto system. So as I mentioned, this is a public key crypto system. So if the sender wants to send some message, it's the responsibility for the recipient to act first. So here she will make the infrastructure. What she will do, she will choose two big large prime P and Q. Ideally, they should be of the same size and they should be distinct in nature. That means P should not be equal to Q. As I mentioned, if you have big P and Q in your hand, you can always make P into Q, which is nothing but N. Now she will compute phi N. As P and Q are two distinct primes, we know that Euler phi function of N, that is nothing but phi P into phi Q, and phi P is nothing but P minus 1 and Q minus 1. See, if this girl knows the values of P and Q, she can compute P minus 1 and Q minus 1 and it product it, and whatever she will get phi N. Like factorization, the efficient algorithm for calculating phi n is not also available unless you have the efficient algorithm for factorization n. If you don't have the factorization of n at your hand, till now there is no efficient algorithm known for calculating phi n. So for this girl it's easy because she knows P and Q. Now she chooses E such that E and phi n are relatively prime. So this step is also polynomial time because Euclid algorithm we can do this. Now she will calculate D, which is nothing but the multiplicative inverse of E. And that can also be computed in polynomial time because we have extended Euclid algorithm at our hand. Now she will publish two things, E and E. So N and E are the public entity. So this N and E she already calculated and she will make it public in her some public place, maybe in her website or some posting at some social media or somewhere. But she will keep with her P, Q and D. So here P and Q will not be used in future, but she will keep with her. But this D will be used in future, and this D is nothing but her private key. Now it's the turn for the boy. So the boy will collect the value of the public key, that is N and E. Now suppose he wants to send the message M to this girl. What he will just make M to the power E modulo N. See, he knows E. This is the public entity, so he can compute M to the power E modulo N. See, all this kind of exponentiation can be done by using square and multiply algorithms, which are also polynomial time. So this can be made into C, and then this is the ciphertext, and he will send this value of C to this girl. Now when the girl will collect the value of C, since she has the value of D with her, C can very easily made C to the power D by using square and multiply algorithm, and you will be surprised to know that this value of C to the power D is nothing but the original M that he wants to send. So she will get back the message. Now if any third party will come to know this C, what the third party knows. See, the third party knows about the value, all the public value, that means N and E, along with the value of C, because C comes through the internet or some insecure channel. Now the attacker knows the value of N, E, but what he doesn't know is the value of D. So to get the value of D from E, he requires the multiplicative inverse of E in phi n, modulo phi n. But as I mentioned earlier, there is no known algorithm like factorization. The attacker won't be able to calculate phi n to get back the value of D. So you can think of intuitively that could be considered as why nobody can break this, or to break this you should have the factorization of n. But as I mentioned, cryptography don't always go in a straight line. There are few attacks, but in a different way, like bidding attacks or small exponentiation attack, which works on RSA crypto system. But when you are doing it for some specific purpose, you have to be very clear that what kind of application you are doing, and based on the application you have to choose the size of the P and Q and all the modality of the schemes. So if you want to know more about this, you can have a look at the chapter 12 of this book, where I mentioned it in a great details. Okay, now let me have some applications of this real life applications of this public key infrastructure or public key crypto system. So now we all use WhatsApp. We all have the WhatsApp group. Now, when we use the WhatsApp group, we all have heard about the term end-to-end encryption. So what is the idea of this end-to-end encryption? We all know about it, but what is exactly the end-to-end encryption? Let me try to explain, but in a very broad sense, not with minute details, because with minute details, it's not possible to explain within the speculated time. So here, suppose this boy wants to send some message to this girl. Now, as I mentioned, like the idea of public key, if he wants to send some message through WhatsApp, the girl should have installed WhatsApp at his machine. So the first work should be installation of WhatsApp. So when WhatsApp is installed at her mobile, it actually prepares two things. One, public key, another one is the private key. So when something is installed at your mobile, at the same time it prepares the public key as well as the private key. The private key is stored at your machine and the public key is sent to the server of WhatsApp. Okay, that's why when you reload or when you reinstall your WhatsApp or when you change your mobile, you see that the security code has already been changed. It is one of the reasons why the security code is being changed, because the public key and private key pair will be changed at that time. So when she installed, at the same time the public key is being sent to the server of the WhatsApp, and at her machine the private key is being stored. Now when this guy wants to send the message to this girl, he first asks for the server to get the public key of this girl. Since the server has the public key of that girl, the server will supply the public key to this boy. Now with this public key, this message is being encrypted, and this encrypted message is being sent through server to this girl. When this girl will receive this encrypted message, the locked message, since she has the private key with her, she can decrypt and nobody else can decrypt. So that's the basic idea of this end-to-end encryption, because it's the encryption and decryption are being done at the two end, and in between nobody can get the message because the secret key is only with this girl. And it says that WhatsApp says that not only any third party, it's not even possible for the WhatsApp even to get the information about the message. But there are many other researchers on this field which says that, okay, there is a technology called backdoor technology through which WhatsApp may get some information. So that's a different issue, but the broad idea of the end-to-end encryption is that nobody else, even the WhatsApp, won't be able to get the message itself. So that's the basic idea. But when doing that, if you look at more carefully, then few things both the boys, girls, as well as WhatsApp should take into picture. That no one else had read the message in transit. The WhatsApp should ensure that. Along with no one else has modified the message in transit, WhatsApp also should ensure that. Not only that, the message really comes from the sender. That means this boy really sends this message to girl and nobody else has sent in the name of this boy. That should also be has to ensure. Not only that, most importantly, later on the sender should not deny that he has sent this message. So it may happen that something she sent and later on some issues came up, and then the boy should not be in any position that he can deny that he has sent the message. So this kind of issues, all the things should be addressed by WhatsApp and all. For that, few cryptographic terms are important. For example, confidentiality, integrity, authenticity, and non-repudiations. And to achieve this, symmetric or asymmetric encryption, hash functions, MAC signatures, etc. So they are all basic primitives of cryptography, and they are basically all big chapters of any book of cryptography. So it's not really possible to explain me all about in each of these important primitives, but they are all required to ensure that the scheme is actually end-to-end encryption. And end-to-end encryption, if somebody is interested, he or she may go to WhatsApp white page thing. So if you type just WhatsApp white page end-to-end encryption with this keyword, then she or he will certainly get the white page that what exactly the schemes are being used. So you find that a lot of integrities are there to achieve all this kind of things. So nowadays we are also very fond of using the online applications like all I already mentioned. So you'll be surprised to know that all the data, when they store the data like Dropbox and all. So for example, when Google store our data, if you pay some money to Google for storing your data, then all the data are being encrypted. So all the data, initial data that you want to upload is basically get it is make into pieces, and all individual pieces are encrypted with different keys. Not only that, these encrypted data are placed in different places, different servers maybe, and all these keys are again being encrypted by using the key management system of this Google. And you'll be surprised to know that in everywhere Google use lots of things like AES 56 or elliptic curve signature scheme. Those who are good in algebraic geometry, for them elliptic curve is quite well known. You will be surprised to know that that part is also used hugely, because elliptic curve implementations are quite easy compared to others, and that's why nowadays elliptic curve implementations are used everywhere. So this, you can see that all the big numbers, so 703072 means that bit of RSA prime. So you can understand that it will contain around thousands of digits in a prime. So that big number prime and abstract algebra and number theory are being used everywhere. Not only that, when we buy something or when we try to connect our client server or our browser from my machine, when it comes to connect with some others, it actually goes through a kind of handshaking protocol. And using that handshaking protocol, these big prime numbers are playing an important role. So you can see that this is not 300, it's actually 907 or something. I forget exact the number of digits, but I need to check this. So it contains around 1000 digits of prime, and it actually I get it by using my small laptop very easily, and that can be done. So this is the acknowledgement. So I am thankful to Google for providing me all the information and necessary images, and I am thankful to my funders for my research, like Department of Information Technology, Government of India, Defense Academy, so Defense DRDO and YZ, Ministry of Defense, DST Serve, DST Matrix, NBHM, JSPS, and Government of Japan for providing me all the financial support. And most of the materials are from internet as well as from this book. So if you have any questions regarding this, so for example, I just want to mention that for higher studies, if you want to go for higher studies in cybersecurity, then there are two very good places in India now. For example, one is Indian Statistical Institute. So the best thing for Indian Statistical Institute is that if you are eligible, so you don't have to bother about your background. So you may be from physics, chemistry, biology, or even statistics, mathematics, computer science, IT, anything. If you pass their entrance exam, then you are eligible to join their course, and that's a 2 years MTech course on information and on cryptography. So it's a very good institute, you all know, and then you can join there if you wish. There is another course going on, and you can see it in internet. This today is the last day for joining that. It's done by Kanpur IIT. It's a certification course where, as I mentioned, Monindra Agarwal and also Manish Shukla. So both of them are leading this idea of 6-month certification course. They have their criteria, but today is the last date. So if you want to go there, you can have a look at this. And so if you have any question or comments, you can ask me. So this is my email ID, and thank you.
Okay, so thank you very much, sir. It was a wonderful session. All your effort really deserve a very good clap from all the participants, everyone. It's time to clear your doubts with the sir. There is a limitation of time, and he's very friendly. He already said he is very happy to clear your doubts.
Good afternoon, sir. I am Priya from an undergraduate student from Kerala.
Good
Okay,
afternoon.
sir, the session was really informative. I am really excited. So my question is, every day we are receiving many spam mails, and sometimes the needed mail is also sent into spam folder. So why this is happening, and what is the algorithm which distinguish the mails?
Well, Google, I mean, as far as I understand your question, so what are the algorithm that is used for selecting the spams, right?
Yes,
Is this
sir.
your question?
Yes.
Yeah. So actually, Google does it. So I exactly don't know what algorithm exactly the algorithm they are using it. But nowadays, AI algorithms are being used for classification. Like some keywords, they also provide. Like if your mails contain, so suppose I am sending some email, and my email contains, say, maybe thousands of participants altogether. They
To know about the image cryptography using the RSA crypto system. How image cryptography is done, image encryption.
image encryption. Okay. So as you understand that in image encryption there are many formats, like it can be black and white, it can be grayscale, or even it can be color itself.
Yes.
So depending on the extension, and we all know that the pixel values, if it's a grayscale image, the pixel values are usually within the range of 0 to 255. So if you are doing it in a big pixel level, then you can, for example, if you want to encode a grayscale image and in a pixel level, then you just encode, you can take one of the images, and that could be considered as plain text, which is from 0 to 256, 255 range, and then encode it. But the point is, you have to get back in an image format. So there are plenty of such schemes available, you can see in the internet. Most of them are lossy. That means you cannot get back the original secret always. But there are few schemes which are also available, which are lossless schemes, in which you can get back the original images. But image secret sharing is also a very well-known topic. I did many works on that. So there some secret sharing schemes are being used, and nowadays I'm just going many schemes, mostly from uh, Chinese co-authors. I mean, Chinese authors are there who are actually proposing lots of such image encryption schemes, and they have mathematically lot of drawbacks. So nowadays I just submitted one paper which is based on CRT KPS, that means CRT encryption schemes, like Chinese remainder theorem based secret sharing schemes, where we found a lot of drawbacks and we attacked them. And also there are schemes where we have already give some attacks and give some extra features to have some more security on it. So not only RSA, you can see image encryption is nowadays is a very common topic where many algorithms can be used there. So you can encrypt by any means. So it's not only RSA, you can encrypt it by any means.
Sir, you mentioned that hackers can access pacemakers. Can
Hackers
they
can,
really can access pacemakers?
yeah, it's not me. It's I got this news in internet. That's why I mentioned the link as well. Yeah, it says that you have to be very close to the pacemaker within 100 meters. Yeah. So what is your question?
So, can they really alter our heartbeats from an external software? Is that possible?
Yeah, according to that report, it's possible, because it's basically senses the pulse of your heart, right? If your heart is not pumping well, depending on the, suppose I am doing some exercise, then I need more blood circulation. So the smart pacemakers have a very small computer inside it, which actually pulses the needs of the oxygen level and all, and based on that it works and it sends blood. Accordingly, it pumps your heart. So since that it has a kind of sensation of having a sense of your pulse, so it's basically kind of beat things. So that control can also be hacked according to that report. Yeah, it's possible, and that can actually cause changes of your heartbeat and all from
Okay, thank you,
externally.
sir.
Yeah.
participants.
Hello.
I would like to tell you that please start your video when you are giving the question, and please put it in the horizontal position. Also, if you can, please introduce yourself before giving the question.
Hello, this is Sarfaraz Mansi.
Can you please join your video, Sarfaraz?
Actually, I'm working in a Mumbai junior college.
Yeah.
I want to do something related to mathematics and computer, so I can improve or improve my knowledge and share my knowledge, and even I can give lectures to other means how it can enhance my curriculum CV, and what is the benefit. I want to do some.
I didn't get your question. So can you please repeat once again?
Sarfaraz, are you there? Sarfaraz? Okay, he will be joining later. Others, any questions? This is a very useful time for you.
Hello.
Yeah,
Hello?
Sarfaraz, could you please repeat your question? I couldn't get it. Yeah.
See, I'm a MSc B.Ed in mathematics. I'm working in a junior college. Okay.
Okay.
From
Yeah.
many years, I want to do something after MSc. Okay.
Yeah.
So what to do, I should do? Means it is beneficial for me as a career, as a financial means. So it will, help me.
Okay, so if you are interested in doing or getting higher degrees in the field of cybersecurity and all, so you can, since for mathematician, it's a good opportunity for mathematician to get into this field, but it also requires a good knowledge of doing problems as well as do coding. So you should have a very good knowledge of doing codes. I mean, in programming language. So to get into some good place. Like
Which
now,
programming language?
like C programming is quite important, as well as Python is nowadays is quite important. So
Okay.
C and Python, and then if you know any language, then it's really easy to get into other languages as well. So at least C is quite required. The important thing is that unless you have a good degree in India, it's really unfortunate that you won't be able to get into some big companies or big institutes. So that's why it's better to go for some higher degrees. As I mentioned, Indian Statistical Institute could be one of the places where you can have a higher degrees for 2 years course, MTech. Then you can go for a job or you can come to academics again. Or if you want to do something like part-time things, so you can go for some certification course. Coursera, you can see this, but it's better to go for with paid course, not like seeing and getting knowledge. Because unless you have the degree in India, it's really, I mean, not in India, I mean, I'm saying that you should have some degree with you. Otherwise, it's really difficult to get in somewhere. So I think you can go for some online course if you are doing it time, then that is also possible. So, but it should be some certification course. Yeah.
Thank you, sir. Thank you, sir.
Yeah. Welcome.
Thank you, sir. There is YouTube. I'm reading this since they can't ask you directly. This is from Mr. Balasubramani, sir. So I'm reading this. I was waiting to hear how the encryption is made complicated to evade third parties' interference. That is the most important part of security. From the student's point of view, they must have gained some knowledge of coding. Hope there was good participation and your gang is happy and tension free now. This is from Balu, sir.
It's my great pleasure. It's Balu sir from IMSC, sir.
Yes, from I am getting this message. I think the same, sir, you are thinking.
Yeah, so thank you, sir.
Thank you, sir. Now,
Sorry, Avishek, it is from Dr. M.S. Balasubramani from Calgary University.
Okay. So,
sorry, sir.
no, it's fine. I mean, my best regards to him. Thank you very much, sir.
Thank you, sir.
I am from Delhi University. Is cryptography is helpful in artificial intelligence?
Yeah, certainly. See, nowadays, when you do something online, sometimes you need to put some captcha, right? So now if you think it more carefully, why captcha is required? So basically in
Yes.
captcha, some distorted characters are being given and you have to recognize it. And the idea is you have to put it correctly, the proper captcha at proper place. Now, what is the basic idea behind this? So by using artificial intelligence, sometimes people are putting their own code for attacking. Now, suppose there is some programming which is running to attack your system. Now, to stop it, it's really difficult for a program to understand a distorted character. For example, if I write A in a very distorted way, only human brain can understand this. That's why people put captcha as a kind of safeguard. But unfortunately, nowadays this AI is again being used to understand the captcha, and there are many success came up that says that even captchas can also be captured by using AI technology. So AI is nothing is very important here, and it really plays an important role not only for constructing things but also for distracting things like cryptanalysis. So AI is very much important in crypto, but it's in a different way. I mean, it's coming, but not main thing of the crypto is to have a good secure algorithm. For that, AI not in a bigger sense it came into picture, but I'm sure within maybe 1 year it will be in a limelight. So it's using, people are using it. Yeah. Any?
Thank you so much, sir, for your patience, readiness to answer the questions. Now participants can ask if you have any doubts, or you can.
Namaste, sir.
Yeah, namaste.
Sir, this is Rakesh from India also. So I want to, sir, ask a question.
Yeah.
Sir, as you said, if recipient created infrastructure as public and private key, okay, sir?
Yeah.
If the sender encrypted message using public key,
yeah,
then how the bad guy cannot decrypt the message using the same public key?
No, the scheme is like that. If you go to the proof of any public key crypto system, for example, RSA public key crypto system, you can understand that. See, if you look at my slide, that M to the power E was encryption to get ciphertext, and C to the power D was the decryption. So if you make C to the power D, that means M to the power ED, and that ED becomes 1. So it's not E and D are used. So if you put C to the power E, then you won't get M. So you need to put C to the power D only to get the M. That's why E and D are not the same, and getting D from E, it's really a computationally hard problem. That's why it's being done. So is it clear to you now?
Okay, sir.
Okay, thank you, sir.
Hello, Avishek sir.
Yeah.
Can you explain the difference between cryptology and cryptography?
So
Is there any
in my
much difference?
no, cryptology, as I mentioned, if you remember my slides, so cryptology is a bigger subject. It has two branches. One is
Yeah.
cryptanalysis and cryptography. So cryptography is a constructive part and cryptanalysis is the destructive part, and both together combines to give you the bigger subject known as cryptology. So cryptology is a combination of cryptanalysis as well as cryptography. So you can say in set theoretic viewpoint, cryptography is a subset of cryptology.
Thank you, sir. One more thing. What about the career opportunities?
Okay. So if you, I may show you. Yeah, just I am.
Okay, it is not necessary to share, sir. You plus,
No, no, no.
please explain.
I just made one thing that will help
Okay.
you.
Okay.
Okay. So I'll just present my share now.
Okay.
So can you see this slide? This not slide, this tab. Is it visible?
Yeah, it is coming.
Yeah.
Yes,
So
now it
as
is
I
okay.
mentioned, yeah, as I mentioned, this IIT Kanpur, they have made this. So see, this is the last date today. 15th August is the last date today. Applications are going on. So here they have mentioned that 1.5 million cybersecurity professionals needed by 2020. So it's in the official website by Kanpur IIT. They mentioned like this. So in IT profession, in future there will be required lot of cybersecurity scientists or cybersecurity experts. Not only that, in India we have a agency called CERT, this Computer Emergency Response Team.
Sir, I think some audibility problems are there now.
Okay, just a minute.
Not clear voice.
Sir, the audio is clear, sir.
Okay, I think maybe the net connection due to. Is it audible?
Yes, sure, sir. Audible.
Okay, so there is one agency from Government of India that is called CERT, Computer Emergency Response Team. So there also there is a job opportunity because that CERT-in, so you call it Indian Computer Response Emergency Response Team, but it's pronounced as CERT-in, CERTIN. If you go to their website, there also they basically are the official agencies who actually give us the information about what are the attacks, and if you have some kind of attacks at your machine, so you just report them. They actually give you the new what are the new attacks or what are the new threats. So there they recruit people. Not only that, in DRDO there is a group called SAG, Scientific Analytic Group, who actually works on cryptanalysis and cryptographic things for Indian agencies. So there also you have the opportunity for things, and also of course in academics you have plenty of such opportunities. So in future, if somebody wants to take it for as a future career, may go for that. As I mentioned, IIT Kanpur already offering such course. There are plenty of such course, but they are quite famous. In ISI also you might have the similar kind of course for your higher studies. Yeah.
Okay, thank you so much, sir. Any other question?
Hello, sir. Excuse me. Hello.
Yeah.
Good afternoon, sir.
Good afternoon.
Sir, I just want to ask that any course is available by the CRSI for the post-quantum cryptography, which can be we can take by the online or any other.
No, not yet. We haven't thought about online courses. Sometimes, as you know, that the main motto for CRSI is to have basically three activities, major activities. Like the IndoCrypt is the biggest, and the national workshop and the instructional workshop. So in instructional workshop, we usually prefer for go for the students mostly to meet the students with few experts. So sometimes we have courses at ISI, Indian Statistical Institute, to have post-quantum cryptography, but you have to look at the website of CRSI to have this announcement. So, but the problem is we have only maybe 80 to 90 participants that we can accommodate, and a huge rush. So you have to be very fast and to, because within fraction of things everything filled. So that thing
Okay,
can be
thank
done.
you.
Yeah.
Okay, thank you, sir. One more thing, sir. How can we generate a large prime number by using the MATLAB?
MATLAB, I don't know, but I can show you in Sage programming. I think the same thing will happen. I'll just show you using this another software called Sage Math that is freely available. So I prefer the freely available because I don't have that money to buy the this MATLAB or Mathematica. So I prefer for the students to use the free version of this. And there is an open source called Sage Math. So can you see my screen?
Yes, sir. I can see it is.
So you can see that it's next prime of this, it produces this big prime. So it's
Okay,
you
okay.
don't have to code anything. It's everything is coded there. So you
Okay,
can
okay.
use this
It
to
shows. Oh, okay, okay. We can generate the prime number of any size. We can
not
give
any
that.
size, of course. It will have the
Okay, okay,
limitation of the machine.
okay,
If you have better machine, this my small laptop, the thing that I
okay,
have showed in my slides are basically from this input.
okay,
So
okay, okay. Thank
it's
you.
yeah. So it's
Yes,
already
yes.
there.
Thank you, sir. Okay, okay,
Okay.
okay. Thank you, sir. Okay.
Hello, sir. Sir, actually,
Yeah.
factorization being an impossible job within a short time, how does
No, no,
actually?
I cannot say it's impossible. It's believed to be impossible till now by using classical machines. That I meant. Yeah.
Yes. Yeah. So, how does actually hacking take place? Because it's a very difficult job.
No, as I mentioned, it's not like always in a straight line. If you go in a straight line, then you go want to make it factorization. But there are few attacks, like bidding attacks. For example, suppose some company wants that they are very transparent about all the things and they want to make it secure by using RSA crypto system to have a kind of bidding options. Like something is selling, this company is selling and it's bidding. So whoever will be the highest bidder will be given to them. But it has been shown that since RSA crypto system is a homomorphic crypto system, like if you encrypt this, if you look at the encryption function, encryption of M1 into M2, it gives you encryption of M1 into encryption of N2. The group homomorphism holds here. That actually destroys the property of bidding. So without knowing the actual bidding value, one can modify the bidding value to a certain extent so that the attacker can get always be the bidder without exactly knowing the what was the exact bidding. So that kind of attacks are available, which are known as bidding attacks. So it's not always that people go for factorizing things, but there are, I just mentioned about a fraction of the whole network security. So it depends on many implementation. For example, theoretically you can do many things, but when it's a time for implementation, the engineers and the mathematicians, they do it. For example, when we write something in theory, we use use something randomly, choose an element randomly. So when you are going to implement this, you have to choose it really randomly. But unfortunately, this you have to generate it using some machine, and machine cannot use really the real random things. So it has to be something wrong. But the engineers, when they are going to implement it, they have to do the best thing that computer can do. So there would be a gap between the implementation and the theory. And based on that part, the hackers usually get into. So hackers always look into the loopholes or the weaknesses of the schemes, and then they get into, and not always breaking the scheme directly. So they some side channel attacks, we usually call it. So they just get into the system using some other things. It's not always due to the scheme. It's mostly due to the implementation, and mostly due to the, I may say that, due to the not very aware users. So most of the cases, the user, they give many things. For example, nowadays the children are using your mobile or my mobile, and they say install something unwillingly, or something came to him and he finds it very interesting and press it, and then your mobile may be in a danger. So it mostly due to the users that security are broken. See that how many participants to whom you are sending. If
Okay.
this is more than the certain value, they will suddenly send it to spam. There are few keywords present inside your email that they target it, and when they target it, if they find that kind of keywords are there, then they will suddenly classify it and they put it into the spam. So there are few filters algorithms are there. I don't know exactly what algorithm they're using, but they are always modifying and upgrading the algorithms. And now you can see that most of the spams they can filter, and they send it to the spam or promotion. And most of the cases, sometimes our useful information, that also goes into that part. So the other way around, the question is how to get out of it. So many research are also going on how to avoid this kind of situation, so that they can send some spam mail so that the Google won't be able to filter. So both. That's why I made it like it's a parallel game going on.
Okay, sir. Thank you. Thank you so much.
I am Rajivan, Employment Officer and Project Coordinator of the Dhanus program.
Yeah.
Actually, we are coordinating this program. I have one doubt, sir. We have started one program called Dhanus. We selected some students from various colleges for getting them to get admission to the various big colleges, universities in India. ISI is our prime aim. Can you tell me, explain the difficulty level of the entrance examination of the PG programs of ISI institutes? Can you explain, sir? Yes. There are different type of PG programs, even in economics also.
Yeah, yeah.
Can you explain the difficulty level of that entrance examinations of ISI? That is what I am asking you, sir.
Okay, so as you can understand that this is one of the premier institutes in India, so the difficulty level of admission is really quite high, and all over the India, many students they appear for this exam. So unless you have a, from your very childhood, unless you have a very affinity towards mathematics, it's really difficult to get into the undergraduate level. Like they offer BMath and BStat 2 courses. So they are basically the cream of the cream students or all over India. So I have seen students who get IIT, JEE, they left this and they joined ISI for their BStat and BMath courses. So there they have very good students. So from your childhood, unless you have the good ability to solve the combinatorial problems, like counting problems, permutations, really difficult to get in. Then it comes about your master's degree course, as you mentioned about the economics course, and there are computer science course as well. There are PhD courses, there are MTech courses. There also, they always have a maths paper with all of you. So you should have good in maths. Unless you have a good love with math, it's really difficult to crack ISI exam. Most importantly, there are two things. One is the elimination paper, another one is the subject paper in most of the cases. So if you are from say physics background, so you will get a paper in physics itself. That's the best part in ISI. So they don't bother about your background, so they always bother about the uh, whether you are cracking their exam or not. So for that, it's a different exam. So you cannot compare it with JEE Main or other exam like NET, SET, GATE or JAM. It's a different exam. So as I mentioned always that every puja has different mantras. So you cannot combine all of them, but there are some intersections. So those who are the students try to find your goal, whether you want to that, and then try to find you the syllabus of that, and try to find the intersection of all the exams, and then you have to do some extra thing for your future purpose. That's more important.
Myself, Alisha. I have a
Yeah.
doubt. While
Yeah.
we do transactions in bank, we got an OTP.
Why? Okay.
And
Transaction
is
in
the transaction we got OTP? And is there any connection with mathematics? And if there is any third person can decode this OTP, is it possible?
Okay, so let me first tell you that maybe say 10 years back when we do this, OTP didn't come. So it's basically many person during that time, they lost their money due to this kind of transaction while doing transaction. So OTP is basically give you a kind of extra protection. It's a 2-level security. Sometimes we might have 3-level security. So when we do some transaction, at that point, we have to put some OTP that comes to your mobile. Now, somebody may know your password, but it's really not likely that he knows your password as well as he is having your mobile with him or her. So it gives you a kind of extra level of security, that saying that, okay, you are basically authenticated with your registered mobile. So the OTP comes to your mobile, and sometimes it happens that it's a more level security where you have to give the OTP comes to your mobile as well as the OTP that comes to your email. That means more security level. That means it's very unlikely that a guy who knows your password of your ATM card, he has or she has the access of your mobile as well as your email. That means it's almost sure that you are that person. So that is the basic idea for OTP, to give you kind of extra security by authenticating you. Now the point is how OTPs are made. There are many other technologies how to make OTP. One of the common methods are basically to use hash functions, mathematical hash functions. So idea of hash function is basically you can think of from a large domain to a small domain. So its codomain is very small, but its domain is very large. But the function has a property that when if from the domain to codomain it goes. For example, if you take an element A from the domain and it goes to FA, that means in a codomain. So if you have A or B or C from the domain, you can very easily compute FA, FB, FC. That means one way is very easy, but it's really difficult. Difficult in the sense is computationally difficult to get back from FA to A. That means if you know FA, then it's really difficult for you to go back FA. So go back A. So you know FA or FB or FC. From there, it's very difficult to go back A, B, or C. So this is the kind of property known as cryptographic hash functions property. There are many other properties, collision resistant, etc. So if some good hash functions are used, then usually the OTPs from OTP is really difficult to get back the original message. And if you look at the agency always say that don't share your OTP with others, and you are getting the OTPs different from different place, different when you use the next time your OTP will come suddenly different. So many of the OTP generation scheme uses your older OTPs. So that's why they say that you don't use your OTP, you don't share your OTPs and all, but it's not very easy to get back. That I can assure you.
Thank you, sir.
Thank you very much, sir. Avishek, sir, many people are asking whether you can share the PPT of this event.
So at this point of time, it's not possible. Maybe in future I may.
Okay,
because
sir.
it has some material that I can't share with you.
Okay, yes.
But of course, you have the video with you, so you get all the screenshots of my screens. So that is possible.
Okay, sir. I would like to say the participants that the feedback link is added and pinned in the YouTube, also in the Telegram group also. So you will get the certificates in few days. Don't worry. So I hope many of your doubts are clear, and it's a very happy day for each of us. We got a lot of useful information too. So I am welcoming Anna Maria to give a small word of thanks for this session. Anna Maria?
Yes, am I
Yes,
audible?
sure, dear.
Okay. Respected resource person, Dr. Avishek Adhikari, the organizer of the webinar, Dr. Vinod Kumar, and dear participants. It's my immense pleasure to propose vote of thanks for this session. And it was really a wonderful session. For many of us students, we are not familiar with such topic. And seminars and talks related to such applicational level mathematics are rare too. And in this current scenario, a talk on cybersecurity is really relevant. The session was really effective and highly motivating. We are all really thankful to you, Dr. Avishek Adhikari, for spending your time and effort for us. And on behalf of all the participants and student community, I would like to express our sincere thanks and gratitude towards you, sir. And the session would not have been a success without the active participation of the listeners. And we have participants from in and around the country, even outside the nation too. And also we have participants from various fields, even other than mathematics. And we are really thankful to each and every one of you for making this program a success. Now, coming to Dr. Vinod Kumar, he's the person behind this initiative. He's spending a lot of time and effort for the upliftment of mathematics students community. And many of us are aware about his initiative, Online Mathematics Exam Series. It's a grand success by now. It has also gained huge media popularity too. And he's also managing 2 WhatsApp groups for maths aspirants. And Rajivan sir mentioned about the Dhanush program. And Vinod sir is the mathematics chief of the Dhanush program, and many programs and lecture series are conducted on the banner of Dhanush too. And Vinod sir, we are really indebted to you for all your support and encouragement. And now I use this opportunity to express a heartfelt gratitude towards you, sir, on behalf of the whole mathematics community. And I would also like to thank Career Development Center Perambra and Rajivan sir for their support in organizing this program. And there are WhatsApp groups for maths aspirants and the Mathematics Exam Series Google group. All the members are mentioned here and for their support and participation in the program. And I would also like to thank Bijumon sir for his support in both technically and creatively. And I would like to thank Ms. Arjuna MP, the anchor of today's session, for beautifully taking us to the session. And there are other members of the organizing committee too, including Ms. Anne-Marie and GROs, etc. And I extend my gratitude to all the members of the organizing committee, and once again to all the participants and Dr. Avishek Adhikari for giving a wonderful session to us. Thank you.
Thank you, Anna. So we are at the end of our session. Those who missed these sessions, they can see the same video recorded in the YouTube channel of Bijumon sir. The channel name is Bijumon R. Please subscribe the channel and you can see the videos there. So we are officially winding up our session. In one word, thanks to everybody, especially to our chief guest, Dr. Avishek Adhikari. Okay, thank you, everybody.
Thank you, everybody, and stay safe and be happy. Thank you.